Okay, this is your review tutorial video for your test 2.1, literal equations, linear functions, and sequence. I'm just going to go through, do a few problems that you might have questions on, so you can use those for reference as you're finishing the rest of your review. I'm going to start with number 4 and solving inequalities. So like we practiced, solving inequalities is very similar to solving equations. The first thing we're going to do is distribute our negative. So we get negative 5x. Negative times negative 7 is going to be a plus 7. And then negative times negative 4x would be a plus 4x. Is greater than, get rid of your parentheses on the right side by distributing, negative 6x plus 8. After we distribute, look to combine like terms. I have negative 5x and 4x. So I get negative x plus 7 is greater than negative 6x plus 8. And now we're going to start solving using our opposite operations. I'm going to move my variables to the left-hand side of my inequality symbol. I'm going to add 6x. Those cancel. We get 5x plus 7 is greater than 8. My constants are going to go to the right-hand side, so subtract 7. 5x is greater than 1. And then lastly, we're going to divide by 5. So we get x is greater than 1/5. So we didn't have to do it on this problem, but remember as you're solving the rest of your inequalities, if you multiply or divide by a negative number at any point, you must flip your inequality symbol. Next, we're going to look at number 8. What is the slope of the line that passes through the points negative 3, 4 and negative 3, negative 4? Write the equation in point slope form. So the first thing we're going to do is find the slope using our formula y2 minus y1 over x2 minus x1. So our points, x1, y1, x2, y2, we get negative 4 minus 4 over negative 3 minus negative 3. Subtracting a negative, we're going to add. So we get negative 8 over 0. Now we know in math we cannot divide by 0. So this tells us our slope is undefined. So with an undefined slope, we write the equation is x equals, because we know it's a vertical line, and then whatever our x-coordinate is. So this time, our x-coordinate is negative 3, so x equals negative 3 would be our equation for that line. Next, we have number 10. What is the 7th term of the sequence using the explicit rule? F of n equals negative 2n minus 9. So because we know it's an explicit rule, that means I can plug in whatever term I'm looking for n. So this case, I'm looking for the 7th term, so I'm going to plug 7 in for n. So our equation is going to be f of 7 equals negative 2 times 7 minus 9. So negative 2 times 7 is negative 14 minus 9, negative 23. So the 7th term of this sequence would be negative 23. Next, number 11, we're going to look at a recursive rule. So the recursive rule tells us f of 1 equals negative 4 and f of n equals f of n minus 1 plus 3. What is the 3rd term of the sequence? So remember with the recursive rule, that's the one where we have to go through each position until we get to the one they're asking us for. So I have to start at f of 1. And then my rule tells me I'm going to take my previous term and I'm going to add 3 to it. So to find f of 2, I'm going to take my previous term, so we're going to use negative 4, and I'm going to add 3 to it. So negative 4 plus 3 gives us negative 1. To find the third term, f of 3, we're going to take the previous term, so we're going to actually look at f of 2, which was negative 1, and add 3 to it, which is 2. So our third term would just be 2. Another way to look at it, your first position, second, third, we're starting at negative 4, and we need to add 3. So negative 4 plus 3, so we're going to give us negative 1, plus 3 is going to give us 2. So our third position, the value is 2. Number 12, write the recursive and the explicit rule for the sequence 5, 1, negative 3, negative 7, negative 11. When you're asked to write the rule, you need to identify two pieces of the sequence. The first term and the common difference. So here, my first term is 5, and the common difference is minus 4. So we're taking away 4 each time. Let's start with recursive. So for the recursive rule, you need two pieces. You need to identify the first term, and then you need the function rule. We've already identified the first term is 5. So that part's done. The function rule, f of n equals, and then we need to take the previous term, and we know we're going to subtract 4 from it. So to write the previous term, we write f of n minus 1, and then the common difference, we're going to take away 4 from each of the previous terms. And that is your recursive rule. Next, we have explicit. So for explicit, we don't need to identify the first term separately like we did for recursive. It will be part of our rule, but we don't have to write it out separately. We're just going to start with f of n, and then you write the first term plus the difference times n minus 1. So f of 1, we know what that is. We've already identified that. F of 1, in this case, is 5 plus our common difference. We've already said that d is negative 4, so we're going to write minus 4 outside of our parentheses, and that would be our explicit rule. Next, we're going to look at number 14. Graph the equation of the line given in point-slope form. So we've been given an equation in point-slope form, and they want us to graph it. Start by identifying the slope and the point they gave you in the equation. So y minus y1 equals m times x minus x1. So our slope is whatever's before the parentheses. So in this case, our slope is 1/2. The y1 and the x1 make up our point. The thing to remember here is that you need to change the signs. So here I have x minus 1. So the x coordinate of my point is going to be a positive 1. And I have y plus 3. So the y coordinate of my point, we're going to do the opposite, is going to be minus 3. To graph, we start by plotting that point, so 1, negative 3. And then we follow our slope of 1/2. So rise 1, run 2. And there's your line. Number 16. Write the equation of the line in slope-intercept form that passes through the points 6, 1 and 3, 3. The first thing we need to identify is our slope. So we're going to use that equation from the front. y2 minus y1 over x2 minus x1. So 3 minus 1 over 3 minus 6. So 3 minus 1 is 2. 3 minus 6 is negative 3. So my slope is negative 2/3. Then we're going to pick one of these points, and we're going to write our equation in point-slope form. So I'm going to use 3, 3. Then we're going to take the slope in that point and put it into point-slope form. So y minus 3 equals negative 2/3 times x minus 3. To get it into slope-intercept form, all we have to do is take point-slope and solve for y. So this goes back to our literal equations. We're just trying to isolate the variable y. So I'm going to distribute first. We get negative 2/3 x plus 2. Negative 2/3 times negative 3. We're left with positive 2. And then add 3 to both sides, because we're trying to get y alone, so those cancel out, and I'm left with y equals negative 2/3 x plus 5. If I were to graph these two equations, they would have the same line. These two equations, though they're written differently, represent the same linear function. So the point 3, 3 would be on that line, as with the y-intercept of 0, 5. Next, we're going to look at problem number 18. So here's your literal equations. We're going to solve for y. So 5x plus 3y equals 18. So if we're trying to isolate y, the first thing we're going to move is this 5x. Because it's positive, we're going to subtract 5x from both sides. So we get negative 5x plus 18, because that 18 was positive. And then our last step, we're going to divide by 3, so these cancel. And then we have to divide this entire side over here by 3. So we're left with y equals negative 5 over 3. That doesn't simplify, so we're going to leave it as a fraction. And then 18 over 3 does simplify, so we have plus 6. So again, notice how solving this equation for y gives us an equation in slope-intercept form. Next, we're going to look at number 22. Convert the following equation to slope-intercept. We're just solving for y again. So the first thing we have is y plus 2 equals 3 times x minus 5. So we're in point-slope form. To get it to slope-intercept, solve for y. So distribute to get rid of those parentheses. So 3x, 3 times negative 5 is negative 15. Then take away 2. So y equals 3x, and then negative 15 minus 2 is negative 17. And there's your slope-intercept form. And then the last one we're going to look at is on the back. I want you to look at number 24. This table is very similar to the one we completed in class on Wednesday. I'm going to go through the last row down here and show you how to get from slope-intercept back into point-slope. So the first thing we need to do is identify the slope and a point from that equation. So the slope, that's easy. That's just whatever's in front of x. So we have 2/3 x. So my slope is 2/3. The point is going to be our y-intercept. We're going to use that as our point. So because slope-intercept form tells me the slope and the intercept, the y-intercept, we can use this as our point. So the y-intercept of 12, written as a coordinate, is 0, 12. And once we know those things, it's easy to put this into point-slope form. Y minus, so here's our x1, y1, 12 equals our slope, m, so 2/3 times x minus 0. Remember, the signs are going to look like they changed because of our formula, so our positive 12 becomes a minus 12. Our 0 is a minus 0. Okay, so finish your review, check the answer key, and then I will see you in class tomorrow.